adding and subtracting rational expressions. Okay? If you're adding and subtracting fractions, they have to have what in order to do that? Same denominator. Same with rational expressions. When I'm adding or subtracting them, I have to have a common denominator, which means I need to be able to find the least common multiple. Okay? The least common denominator, least common multiples. That's what we're working on there. So if you have something like a over c plus b over c, you get a plus b over c. Same with subtraction. If you have 3x over 5x squared plus 7 over 5x squared, I get 3x plus 7 over 5x squared. So these are pretty simple, standard ones like that. So how do I add and subtract these ones together?
So the first one will be 7 plus 3 over 4x.
Okay.
And then the second one will be 2x minus 5 over x.
Well, let's finish this one.
Okay.
If I have 7 plus 3 over 4x, what's that change to?
7 over 4x.
And then what does that change to?
5 over 2x.
5 over 2x. So we always want to simplify and get it into the simplest version we can. Okay?
Yep.
5 over 2x. Now, over here, what do I do?
2x minus 5 over 6. 6 plus,
Or x plus 6. Is there anything else I can do from there? No, so this is the simplified version. I leave it like that. This is the easiest part of your homework.
Awesome.
Okay, that's the easiest part. The other parts aren't hard. It's just going to take more steps and more time. Okay? Adding and subtracting with unlike denominators. If they do not have the same denominator, hey, focus on this. We'll worry about that in a minute. You're okay. If they do not have the same denominator, then that means I've got to get to the same denominator. So like if it's a over c plus b over d, I'm asking myself, what does this side not have that this side has? Oh, a d in the denominator. So I multiply the top and bottom by d, I get ad over cd. On the other side, I'm asking, what does b over d not have that a over c does have? Well, it doesn't have a c. So I multiply the top and bottom by c, so I get bc over cd. And I get AD plus BC over CD. You can always find a common denominator of two rational expressions by multiplying their denominators together. So I can always cheat. If I can't figure out like what the least common denominator is, I can always just multiply them by the opposites. Okay? It might take more work and more time, but I can always do that. There's always an easy way out. Okay, if I want to find the least common multiple of these two items, what do you think I need to do first? To 4x squared minus 16 and to 6x squared minus 24x plus 24. Take stuff out, good. So what am I going to take out of 4x squared minus 16? 4, and you get x squared minus 4, right? What does x squared minus 4 break down to? Okay, beautiful. Now, let's look over here and break this down. What can I take out of there? 6, and you get x squared minus 4x plus 4, yeah? Okay, how does that break down?
X minus 2, no.
Mm-hmm.
Yeah,
X
x
minus
plus
4, x.
Well, I had lots of different things.
Plus,
No, not minus 2 plus 2.
minus.
I need something that multiplies to give me positive 4 and adds to give me negative 2.
Okay.
Yes, adds to give me negative 4.
-2.
So negative 2 and negative 2. Okay, so I have 2 of these, so I don't need to write 2 sets of parentheses. I can just write it as squared. Yes? Now, to find the least common multiple, okay, the LCM, I'm looking between this and this and I'm comparing them. I'm taking the larger of everything, okay? Now, here's the deal. I actually need to break this down a little bit further, okay? Because 4 and 6 can break down. What does 4 break down to? 2 what? Squared. And what does 6 break down to?
2. Oh shoot. Times 3.
2 times 3. Okay, now I can look at these and find the least common multiple. Over here, I have a 2 and I have it squared. Over here, I have 1, 2. Yes? This has 2 of them. This has 1. I'm going to take the larger one. Okay? Do I have any other constants over here?
You don't got a 3 over there.
No, but I have a 3 over here, so I'm taking the larger one of those two things. Okay, over here I have an x plus 2. Do I have an x plus 2 over here?
No.
No, so I take the x plus 2. Over here I have x minus 2. Over here I have x minus 2 squared.
Is that the right one?
Yes, take the squared. What they're going to do is they're gonna combine this back together for your answer in your book to say 12. Because 2 squared is 4, and 4 times 3 is 12. And then you're gonna have 12 plus, or 12 times x plus 2, x minus 2 squared. This is your least common multiple of those two original equations. You're literally taking the bigger thing of each and just piecing them together. Okay? Now, we get to something like this, where it says add 7 over 9x squared plus x over 3x squared plus 3x. What do you think I need to do first?
Need to find the denominator.
Okay, but I need to find a common denominator, which means what do I need to do with these two denominators first?
No, you have to.
Yes, find the least common multiple between the two of them, right? Okay, so does this break down?
Yeah.
9x squared breaks down. I can take something out of 9x squared. No, it's just 9x squared, there's nothing to do there. I can't factor anything. So I have 9x squared on that side. On the other side, I have 3x squared plus 3x. What can I take out of that? 3x, and you're left with x plus 1. So I'm going to change this to say 3x, x plus 1, okay? Now, between 9 and 3, what is larger?
9.
9. Between x squared and x, what is larger?
X squared.
Okay. And then I have an x plus 1, which is larger than nothing on this side. So over here, I have a 9x squared. Over here, I have a 3x, and I have an x plus 1. What is missing from this side that this side has? An x plus 1.
Yeah.
So I multiply this top and bottom by x plus 1. Now, what is this side missing that this side has already?
An X squared.
An x squared and what else? Look, this is only what number?
3.
What number is that?
A 9.
How do you get 3x to 9x squared?
Times 3x.
Times 3x. So I'm going to take this section and I'm going to multiply the top and bottom by 3x.
I have a question.
What?
So like, basically you have to find like what difference is only like in the denominator.
Yes, only in the denominator. Now, up top, I FOIL. What's 7 times x?
7x.
And 7 times 1.
7.
And then on bottom, I'm going to leave it as 9x squared times x plus 1. I don't need to factor that in. Okay? Now, over here, let's do this first. I'm adding this, right?
Please, pardon this interruption. Miguel Ringer,
Okay.
please come to the front office.
Over here, what's
Miguel
3x
Ringer,
times
please
x?
come to the front office. Thank
3x
you.
squared up top, and on bottom, I have 9x squared, right? X plus 1. If for some reason the bottoms don't come out to be the same, you've done something wrong from the start.
Alright.
Okay? Now we combine like terms and add these little suckers together. I only have an x squared here. We put it in order of operations. 3x squared plus 7x plus 7 over 9x squared x plus 1. Now, can this top portion here, 3x squared plus 7x plus 7, be factored out?
Yeah.
Can you multiply something to give you 7 and add to give you 7? The leading coefficient of 3? No, so I leave it,
7 on 1.
okay? So I just leave it. One more, and then I'll give you homework. Okay, now we're going to subtract, okay? Now, what do I need to do first? Okay, so what can I take out of this bottom one? A 2. So you have a 2, and you have an x minus 1, yeah? Okay, what can I take out of this? How do I factor that one?
Oh, no.
What multiplies to give me 3 adds to give me negative 4?
4 and 1.
Yep, negative 3, negative 1. Okay, now look. I'm going to just write that here so that I remember that I changed it. Okay. Okay, and I'm going to write this one down here so that I remember that I changed it. Now, what is this side missing that this side has?
X minus three.
So I'm going to multiply the top and bottom by x minus 3. Okay? What is this side missing that this side has?
2.
2. So I multiply the top and bottom by 2. Okay? Now, over here, that means I have to FOIL. X times x is,
Squared.
and x times 2,
2x.
and negative 3 times x.
3. Negative
So what does that give me together?
Negative one.
Yep, negative x, good. And negative 3 times negative 2, or times positive 2,
Negative 6.
negative 6. On bottom, I'm gonna leave it 2, x minus 1, x minus 3. Listen, doesn't matter which order these are written in, as long as they're written in the same order when you go to do the next one. Okay? So from there, we are subtracting, yes? Over here up top, I distribute this in, I get 2 times negative 2x, negative 4x. 2 times negative 1, and then on bottom, I'm just rewriting it to x minus 1, x minus 3. Okay? Now, I add, subtract, do all that fun stuff. I have an x squared, now x squared over here, so it's just x squared. What's negative x minus negative 4x? Nope.
Wait, there's negative.
A negative.
What'd you say? 3 what? 3x. Negative, double negative is a positive. So I get 3x. Now, what is negative 6 minus negative 2? Negative 4. And on bottom, I have this 2x minus 1, x minus 3. Now, I've got to double check. Can this be factored? What multiplies to give me negative 4 adds to give me 3?
Negative 4 and 1.
Switch that.
Negative 1.
Negative 1, positive 4. So I have x minus 1, x plus 4 over 2, x minus 1, x minus 3. What's going to happen now?
The x minus 1 cancels out.
Boom. So you're left with x plus 4 over 2x minus 3. And that is how you're going to see your simplified answer. Okay? That's what you're working on 5-4 tonight. Those things. Tomorrow, we're going to start doing this. We're going to have complex fractions, which means it's going to say something like 3x over x minus 2 over
Oh no.
12 over
Oh no.
x squared minus 4. That's why I need you to get this individually down first. Okay? Because then we're going to do it double time. Complex fractions.
But you definitely.